Hello guys, welcome back to Baritoni's Projects. Today's video, I've made a piece of software to program a Raspberry Pi Pico. I've also been creating PCBs for my remote firing system for the 4th of July, which is coming up very soon. Happy 4th of July to you all. This video is just to show you how the software works. I think it's really cool and it's super useful, and I wanted to show you what I've been up to for the past couple months. So, first of all, I've been designing PCBs mostly for the firing system because usually the firing system looks like this. So, it's out the way. So you have 3 8-channel relay modules with the Pico on it. But I've been trying to design something that looks more like this. So it's fully enclosed. As you can see, the footprint of this is much smaller, which is what I want. And I'm on the final revision. It's coming in a couple of days. That's my final revision. But I was like, let's say I wanted my friends or family to try and make their own fireworks show. I wouldn't ask them to learn how to use Python to program the Pico, like this one. That wouldn't make any sense. And for the time that they wanted to make their show, it wouldn't make any sense. So, me and ChatGPT have created a GUI to interface with this through your web browser, and you don't even have to be online for it. So first of all, I'm on Linux right now. I'm running Ubuntu. It's just a file right here. It has server.py and it has the index.html right here. By the way, the download link is in the description. It's right here on my Google Drive. It's shared with anyone with the link, which can be linked in the description. Feel free to download it. It's totally free. I'm going to show you how it works now. So you don't have to do this. You can execute to get this to work, you have to execute the server.py file, which I'm just doing it through my terminal because that's easiest for me, but you can do whatever you want. So I'm just going to do Python 3 server.py, and it should run something like this, and it should be running on this. So you click here, open link, and you get this right here. And it's open on your web browser. You can see it's right there. It's local. It's on port 5000. I'm going to grab my cable right here. It's going to be hard to plug it in with the phone, but I'll try. Plug in the cable. Just like that. And you can see I've already tested a script, so it's working right here. But what you do is, oh, by the way, my first GPIO pin on this thing is totally fried. So that's why there's not an LED connected to this one right here. I know it's kind of blurry. I can't get the camera to focus. Yeah, that's why there's nothing connected there. So let's say I want my first pin to be number 1, which would be this first LED right here. And because this is for the firing system, so you want your GPIO pin 1 to fire, and then 3 seconds of delay, and then the next cake will fire. So you can basically say, I want, like, for example, this mortar to go off, and then I want 5 seconds before the next mortar to go off, or cake, and that's how you program that. So GPIO pin 1, let's say this is in not milliseconds. They're in like tenths of seconds. I don't know what that's called. I'm pretty sure it's milliseconds. Let's say I want 1.3 seconds, and then I want GPIO pin 3 or 2 to go, and then let's say I want 3 seconds, or that'll be too long for 2 seconds to go, and then I want GPIO pin 5 to go, just like that. And then I just click upload to Pico, and there's a little green thing should show up. It says upload successful. Pico will run a program on reset. So it's plugged in right now. It should have gone through this eReport port all the way into it. And the only thing that this requires for this to work is a Raspberry Pi Pico with MicroPython installed on it, and this be connected at I think it's like slash dev tty slash, or not slash, ACM0. That's the port that has to be on it. Oh, this ChatGPT, me and him figuring out. That's what port you have to be at to figure it out. Let me go back to the website on my browser, like that. And sorry, I know this is a hassle. I'm going to unplug it. Okay, so unplug right now. Plug it back in. You should see a little green thing like that, and then it goes. So 1, then 2, and then it should be like what, 5 should go. There we go. It goes just like that, and then it stops. And the way this works is that, so this is an index.html file that's running through the server.py file. You put this in, and it makes a main.py file based on the variables you input here, and then it puts the variables, it puts the main.py file that created on the index.html file through the TT/ACM0 port, and it flashes it onto this, all through this software easy. So if your parents or anybody doesn't know how to program, they just can download this, and they can make their own show or anything you want straight off this. No programming required, nothing. All you have to do is a Raspberry Pi Pico, MicroPython, and it's in the certain USB port. And the ACM01 is the default USB port for Linux. This should, in theory, work in Windows as long as you get it on the same USB port that I'm talking about here. It's also free to download. It's on my website. You should totally check it out. Both will be linked down in the description, the website, and the download link. It's right here. As you can see, it's calling Firing GUI right here. It's just right here. And my firing system only has 6 relays. The new one I'm making at least. So this one only has 6. But I could design one with all like 24 pins of the Pico. If you want to see that, just comment down below. Next thing I've been working on is my design. Obviously, here it is right here. It's just a Pico right here connected to a transistor, which lets the 3.3 volts at 300 milliamps rail from the Pico go through the relay. Don't forget about the flyback diode. That's important. Through the relay. And it also lights up this LED because this one's also connected to BCC, as you can see right here. And then it's connected to ground, just like that. Then I have a continuity tester to make sure your eMatch is fully connected, which just puts a little bit of current through the eMatch. And then when the relay is fired, the full current goes through and lights it. So that's what I've been working on here. I'll update you guys on my website as well if you want to check that out. This is super cool, though. I'm really proud of myself for this. If you want to check it out, it's totally free. I totally want to see if it works on Windows, so check it out and tell me if it does. Anyway, guys, have a good day. Thanks for watching.